Good evening, everyone. Thank you so much for joining us for tonight's lifelong learning lecture. Tonight, we have Ken Mahan, lead meteorologist from the Boston Globe, and he's going to do his presentation on extreme weather events, increase efforts to protect lives and property. So before we begin, just to let you know, you've all been muted upon entry, and we just ask that you remain on mute to avoid any unintended interruptions. Links to our online evaluation forms will be put into the chat. We welcome any feedback you have about tonight's lecture or any topics you'd like to suggest for future lectures. And at the end of the talk, Ken will be taking questions at the end. So we would just like to ask you to please drop your questions into the chat. We'll be looking at those at the end and answering any questions that come in. So please just hold your questions until the end of the lecture.
Okay? Len, is it
Yes.
okay? Good?
Excellent.
Good. Weather. I hate weather.
All right, now you should all be muted. All right, so without further ado, Ken Mahan.
Sarah, thank you so much. I really appreciate the opportunity to talk about weather, especially with the Framingham Public Library. I used to live in Framingham, love the city, and this is my second time doing this with FPL, and couldn't be more appropriate. Most of you may have already learned that there is a nor'easter in the making for this holiday weekend, which, gosh, we haven't had a nor'easter in October since 2021. So I've been sort of hammering all the weather models, looking at all the weather maps over the last 48 hours. And unfortunately, everything's coming to agreement that we're about to have not a direct hit or a full-blown nor'easter, but geez, it looks like there's going to be a pretty powerful coastal storm that will turn into a nor'easter Sunday afternoon, and then really ramping up Sunday night and pushing through the holiday on Monday. My quick forecast for it, talking for Framingham, 30 to 40 mile per hour wind gusts, maybe a rogue up near 50, and some pretty heavy banding pushing through the region. Rain totals through Monday night into early Tuesday, reaching about 2.5 to 3 inches. So hopefully not enough for extensive flooding, but if you do find yourselves having to be on the road on Monday, just take extra time, because it's basically going to be like a tropical storm, but the nor'easter this time of year doesn't have all of that 80-degree sea surface temperature to feed it into a named storm. So this is going to be a textbook nor'easter coming up. But that being said, extreme weather shifting through New England, and then the increase in efforts to protect property, lives, infrastructure, etc. And again, I'm super thrilled that you all are taking some time to join me to talk about weather. Meteorologist for the Boston Globe. I bounced around news stations across the country, found a home. I'm from Worcester, Mass originally, so happy to be back home and working for the Boston Globe for the last couple of years. Been passionate about weather ever since I can remember. It's funny, my mother was, my grandmother was pregnant with my mother in the hospital at Worcester City Hospital on that June tornado in 1953. So that's where I sort of feel the connection was with me in weather. But then when Hurricane Bob came up into New England, I was on the back porch and my parents to get me to safety. So I'm excited to join you all. It is changing, and New England is experiencing more severe weather events versus the rest of the country. That's pretty alarming. There have been over the decades significant extreme weather events over portions of the country, and they've built infrastructure around sort of the extreme weather that they would experience. But New England, home snow, especially during winter, nor'easters are common. And eventually we've seen sort of this change, this shift with more extreme heat, flooding events, tornadoes, tropical systems, you name it. New England has really experienced a sharp increase at a faster rate versus the rest of the country over the last handful of decades. I think just last fall when we had a record-setting number of wildland fires and brush fires across New England, portions of Massachusetts, New Hampshire, Connecticut, dealing with wildfires. That's something new, or something really uncommon across the region. So we're sort of filled out our bingo card as far as weather events for New England as far as what can be a typical year. And unfortunately, it's changing from rare events to more uncommon and common events across New England. Tonight, we'll talk about extreme weather. We'll define it. We'll sort of as to what that means as far as extreme weather is concerned. We'll take a look at how climate change is contributing to these things, and then we'll dive into historical trends, temperature, precipitation, severe events, tropical activity, sea level rise, coastal impact, etc. Review a few handful case studies, and then we'll reflect on what Massachusetts, what the region as a whole is doing to try to curb the impacts from extreme weather, especially since they're becoming more common across. Extreme weather is defined as weather events that are rare or unseasonal for a particular place and time. The Northeast, unfortunately, has seen a great number of extreme weather events increase compared to the United States, like I mentioned. And this chart here shows the number of billion-dollar plus disasters across the Northeast, dating back to when they started tracking billion-dollar events in the late 1970s. And it doesn't really take a lot of thought to see the trend over the last 10, 15 years or so, with the number of events increasing across New England. And it's not held to a single category. Those shades, that deep green on the 2024 bar shows the number of severe storm counts drastically increasing. We've had tropical cyclone activity push through. If it's a tropical storm, I think of Tropical Storm Henri in 2021, pushing up into New England, stalling just offshore, just dumping rain, pulling moisture off the Atlantic. These events are becoming more common, and that includes drought. This fall, last fall, extreme drought across Massachusetts, all of New England, something that's been unprecedented compared to years past. So it's not just held to one individual severe weather event, and climate change is a leading factor contributing to the increase in the frequency of extreme weather events. The average annual number of billion-dollar disasters for the Northeast is 3. We're looking at over the past 4 years, we've seen 6, 8, 11, 12, double, triple, quadruple the amount of extreme events in the Northeast just in the last 4 years alone. Already in 2025, we have seen 18, I should have had 2025 there, we've seen $18 billion disaster events across the US. The average for a year is 20.4. We still have a handful of months. We have this nor'easter that's going to wreak havoc from basically every East Coast state, from Florida all the way up into New England as we get into Monday. That surely I would probably come into play when it's all said and done, with strong winds, coastal flooding, and damaging wind gusts that will surely knock out trees, cause damage, etc. But we'll surpass the average number of billion-dollar events across the country, and we've already done so for New England this year already. So the climate change connection. Climate change alters the baseline conditions for localized weather events, making events become more severe. It's like changing the rules of the game. Something that was once rare is now becoming more common. And the two major pillars, warmer air temperatures, warmer sea surface temperatures, they have contributed to a significant change in frequency, intensity, duration of severe weather events across the globe, but particularly in England. And essentially, we'll dive into it here in a essentially, you think of a warm atmosphere. A warmer atmosphere holds much more heat, much more water vapor. And when there's more water vapor in the sponge, then that means that we have more of a tendency to wring out that water in terms of flooding, heavy rainfall. And you think of New England, New England is a region with mountains, the green, the White Mountains, the Berkshires, the rolling hills of Worcester, all throughout the metro west of Boston. There is so much variability in our where just a single storm that produces moderate to heavy rainfall can lead to excessive runoff, finding low-lying areas, towns, properties, roadways, etc. And that can lead to some real significant problems as we've seen over the last couple of decades. But greenhouse gases, unfortunately, in the atmosphere have doubled since 1980, with influence, the available energy increasing by 50%. More carbon dioxide, methane, water vapor absorb the trapped heat from escaping, and that keeps the planet hotter and increases weather events. Sometimes the weather pattern will hold a certain amount of water vapor, but if it goes across a particular part of the ocean where there's extremely warm sea surface temperatures, the rate of evaporation increases tenfold, and all of a sudden a storm that may not have produced much precipitation at all rapidly intensifies, and then we end up with a significant weather event that will go into the books. Same thing happens over land. But how climate change impacts weather? I touched base on this. The warmer the air, the more moisture it could hold. For every degree warmer in the atmosphere can hold 4% more water vapor, leading to more intense rainfall, increasing the risk for flooding. And New England is very flooding prone with those rolling hills, the mountains, the coastal plain. We have these right along the coast, including Portland, Portsmouth, New Hampshire, Boston, towns and cities along the Cape, the islands, southern Rhode Island, that become more prone to flooding because a coastal storm like this nor'easter, which already the National Weather Service has issued a coastal flood watch, because when you have northeasterly winds pushing inland, then that's going to drive already choppy waters with what is forecasted to have breaking waves of 7 to 10 feet. That's going to splash up over water barriers. That's going to spill onto coastal roadways, get into properties, erode beaches, make it even more problematic for future storms. Become more destructive, because when areas become more warm or more prone to extreme weather, then they don't return to normal faster than the next storm comes into the picture, and drastically as well. Sea levels rise. The warmer the atmosphere expedites rising sea levels by reducing the ice cap, by making the rate of water, these polar caps that have been locked in for centuries, increase the seas pretty quickly. And I tried to tame it down, because it's not something that we're going to see over a year, but we've been monitoring and seeing it happen over decades. And that just has changed, that the coastline can handle these coastal storms, and not in a good way, unfortunately. This raises concerns over infrastructure. What are folks doing to try to mitigate these risks, which we'll dive into later on in the presentation. But the facts are that, unfortunately, the extreme weather events are increasing more, and that's because of climate change, with sea surface temperatures rising, and then the atmosphere rising, and air temperatures as well. 2023 and 2024 were record-setting years for the warmest the globe has ever been. That is alarming. You can see that dashed mark across the middle of the graph there. That's the average temperature from 1991 to 2020. So we're not pulling or comparing this data against weather information collected from the 1800s or the 1900s. This is within our lifetimes, and we could see just how the difference is compared to a subset of 30 years from 91 to 2020. In 2025, that thick maroon line that isn't complete yet, since we're just in the beginning of October, we've seen the third warmest year on record across the globe, which has led to extreme weather events. That is why we are seeing the record number of billion-dollar disasters across the US, across the Northeast, in consecutive years, 2023, 2024, we will shoot above average when it comes to billion-dollar events, excuse me, for 5. It's on pace to where we may never see, and this is very alarming, we may never reach below this average again, unfortunately, because the atmosphere, especially if you think globally, to try and reduce that heat across the globe will have to take years of below averages, which just doesn't seem plausible at the rate of warming increase that we've seen across the globe. So there's a chance that 5 years from now, 10 years from now, we'll never be below this average threshold again from the baseline of 1991 to 2020, which is very alarming. In terms of sea surface temperature, we're following the same feat. Again, compared to that baseline of 1991 to 2020, that 30-year norm, we saw 2023, 2024, the warmest on record. 2025, very close third for the warmest the globe's oceans have been on record. And this is data that goes way back to the mid-1800s. And unfortunately, I still don't think that there's going to be a time where we reduce or go below that average again. It just doesn't seem plausible. We have these sort of seasonal normal weather patterns called El Nino, La Nina that influence our atmosphere's behavior dramatically. Even with La Nina, which is a cooling of the sea surface temperatures off of the west coast of South America, the atmosphere does usually cool down. But the last 2 years, we've seen either neutral conditions or La Nina in place, and we still have ended up with at record or near record sea surface temperatures. With warmer seas, the water releases more water vapor into the atmosphere, and this fuels more violent storms. Now, taking it from the globe, shrinking down to the US, this is where it gets really interesting in a matter of how this actually impacts. The average annual temperature across the US has been steadily above average since 1996. Right there, I highlighted, committing to the baseline for the average annual temperatures for the last 100 years, it's been well above average. Our coolest years dating back to 1996, hardly below average. We haven't seen a significant colder than normal year since 1977 and 1978. 2024 was the warmest on record. And in 2025, again, we're pacing that top 3 finish for the warmest temperatures, air temperatures across the United States. There's a 3% chance for the United States to dip below the 30-year average again. That is remarkable. I've been forecasting for over a decade, and as many times as I've run all of the longer-term climatological models to try and gauge if we're going to get into a cooler cycle. We've been in cooler cycles before, but the cool cycle is now redefined at this stage of the game because the average temperature has increased so dramatically over the last handful of days that our baseline, our normal, is now elevated. So cool isn't the cool that we used to see back in the 80s or the 70s. It's unfortunately still very much elevated compared to the norm. So that asks, let's dial it in even further. How are temperatures faring across New England? Well, New England is faster rate than the rest of the world. I went through all of the available data through the World Meteorological Organization, through subnetworks like the UK Met. Still warming at this rate anywhere. And this is going back data deep into the 1800s, 1895. The average temperature has jumped 1/3 of a degree per decade versus under 1.1 degree across the global average. That's over triple the amount of rate of change. Why is this happening? Well, we are at the Gulf of Maine, the northern Atlantic Ocean, and the proximity to a warming sea doesn't help our cause at all, because being so close to the ocean, our weather patterns are highly influenced by what's going on in the northern Atlantic. Our winters are becoming much more wild, or mild, I should say. Well, wild is true too, but more mild in this case, because with the ocean, which holds on to heat longer than the atmosphere does, doesn't cool fast enough during the winter months. The coolest points of the ocean happen in February and March, and it's not as cool as we've seen since the 1970s. So therefore, our atmosphere has become warmer during the winter time. And unfortunately, that's a consequence. I think back to 2020, the winter season of 2023 spilling into 2024. So 2 winters ago, we had what I would deem a snowless winter because of, yeah, we saw snow. It was nearly as much snow as what we've seen for an average. But northern New England has a huge ski and snow sport industry, and they ski and snow sport resorts closed permanently because they relied on naturally falling snow and didn't have the machinery to produce artificial snow. And that was eyebrow raising because both of those ski resorts, family operated, one was purchased by a corporate entity, but they couldn't hold on to it. And being sort of dependent rather on naturally occurring snowfall is a major risk, unfortunately. Fortunately, though, on the other hand, for those that have survived, they were able to leverage, the freezing temperatures, although dwindling across New England, to be able to stay in business. But I'll tell you, I stopped skiing 2 winters ago when I went to the mountain, and it was more of an ice sheet than natural snow. So do as you may there. But how do warmer temperatures impact heat waves across the region? Well, excuse me, since 1961, New England has seen the highest jump in heat wave intensity, with the heat season extending over a month. This is a really interesting chart here because not only does it look at heat wave frequency, which has increased almost by double over the last 10 years alone across Massachusetts, Boston, Framingham, Worcester, Springfield, Providence, going up into southern New Hampshire, Concord, Manchester. All of these major weather reporting sites have all the same thing. Nearly double the amount of heat waves per year. We went from 1 to 2 to now to 2 to 4. And you can see that circled in the heat wave frequency. The heat wave season has extended dramatically as well. We have more days in the beginning of summer, June, May, seeing more 90-degree days, October, September, seeing more 90-degree days. So we're seeing summer swell on both sides. That hot air is becoming much more warm and excessive. And a heat wave in New England is defined as 3 consecutive days of 90-degree temperatures or warmer. This past summer, we had 4 instances in Massachusetts where a weather reporting site saw heat waves. And again, that's over double than what we've typically seen over decades prior. Intensity for heat waves has increased across Massachusetts, significantly across greater Boston. Boston itself, the weather reporting site sits at Logan Airport, so it's a little bit influenced by the cooler air during the summer, relatively cooler air, because you think of air temperatures reaching 90 degrees or higher. Sea surface temperatures this far north don't get that warm, but the warmer sea surface temperatures will keep the air elevated or not as cool during summer stretches. But we've seen the intensity of heat waves build across Massachusetts as well. What does this mean in terms of precipitation? Precipitation in New England has also increased. which is, it's interesting because I think of like the last 3 months, we've had hardly any precipitation. Nearly all of New England, especially Massachusetts, is in a drought. But when you take the lens off the camera and you zoom out to all of New England as a whole, with a warmer atmosphere, there's been a parallel increase in precipitation across the region. The average annual precipitation in New England has increased by 1/2 inch per decade and over 1 inch per decade since 1960. It goes back to that sponge effect. A warmer atmosphere holds more water. A larger sponge holds more water. But if you wring out that sponge, a storm system wrings out the atmosphere, you get a tremendous amount of water falling from the skies. This is one of the fastest rainfall increases in the world. And with these two elements combined, warmer sea surface temperatures, warmer air temperatures across New England, you're going to see more frequent rainfall events that are more extreme. Fortunately, this summer, or I should say spring leading into the first half of summer, we had a very interesting setup where the jet stream hovered a little bit to the north of New England, allowing it to be much warmer, but the storm track ended up going more north of Massachusetts and producing less rainfall, particularly this summer versus years past. And the reason for that is because warmer air is pushing more north into eastern Canada. You think of Montreal, Quebec, they're becoming warmer now. And so our jet stream, which is the highway storms take across the country, west to east across the country, this particular year, with no real major La Nina or El Nino event in place, our jet stream meandered north, and that set us up where we had misses, for which introduces a whole nother problem. If we're not getting precipitation, we end up in flash drought, which we saw last fall and we're experiencing this fall. For New England as a whole, since 1936, we've had many more instances of above average precipitation, and that trend is going to continue to increase over the year. What does that mean? Precipitation from heavy storms has increased 70% in New England since 1958. I think of this example coming up, over the holiday weekend from Sunday night through Monday. This coastal storm, the temperatures in the northern Atlantic are pretty darn warm. They're much above average. They're not record breaking at this moment because we are in October, but they are very much above average. And we're going to see this storm push up and sit just off of Long Island Sound, just south of New England. But as it turns counterclockwise, it's going to be drawing in so much moisture off of those warmer than average seas, and it's going to allow for what I call training storms, so storms to regenerate over themselves and push into New England over the same areas multiple times. Framingham may end up with 3, 4, 5 different sort of rain events consolidated from Sunday night through Monday, even lingering into Tuesday morning, although shouldn't be as intense. But this is because the system is tapping into moisture funneling in from the northern Atlantic, which in turn has been able to evaporate more water from the sea surface temperatures at a faster rate and continue to fuel the storm because there's more heat content in the ocean. So the distribution of flood risk versus average loss due to flooding with forecast means that over the last couple of decades, particularly with data from 2020 to 2025, so we're not really through 2025 yet, but we're seeing an increase in property damage, more loss in New England. You look at the West Coast, that instance of loss is mainly due to wildfire risk because their wildfire season has grown in intensity, frequency, and duration tremendously. And there's been many millions of dollars lost over the last few years. But for New England, it comes down to flooding. We see the rate of increase across New England above average across the country. So how often do 1 in 100-year storms happen? How often do 1 in 50-year storms happen? How often do the apocalyptic 1 in 1,000 floods, 1 in 1,000-year floods occur in New England? Well, the return period for these 1 in 100-year floods pushing into New England has increased dramatically over the last handful of decades. The Mid-Atlantic is the worst of all, but New England, coastal New England, pushing into New Hampshire, Massachusetts, has been above average. And that is a tremendous concern, because then a separate conversation for a different day is how do insurance companies react to this? All of us have seen an insurance rate increase on our property within the last 2 to 5 years, probably multiple times during that stretch. And I would be willing to bet that 9 times out of 10, it's because of the risk of extreme weather impacting the flooding across New England. Severe weather and hurricanes. A warming atmosphere could hold more moisture. We have identified that 4% more moisture, or 4% more water vapor in the atmosphere per degree warmer. You think of how warm the atmosphere increased over the last decade or so. When you pull it together, you're talking about a degree, 2 degrees in some spots locally. That's a good amount of water. 8% more water in your cup, 8% more water in the atmosphere. That eventually makes its way down to the surface, and most of the time that happens during the event of a severe thunderstorm, flooding event, coastal storm, as we're going to see. And unfortunately, that rate is continuing. A warmer ocean can evaporate more moisture into the atmosphere pretty easily too, and that makes it really challenging to forecast, especially how much rain is going to fall, because there's more supply in the air. And sure, as a meteorologist, there's forcing mechanisms that I can pinpoint to say, hey, there's going to be a cold front pushing through and driving warm, moist air vertically into the atmosphere, right over Framingham, north through southern New Hampshire, south into Rhode Island, and I can pinpoint where it's going to happen. But when I look at the atmosphere like a 7-layer cake, and I see, wow, there's a lot of water vapor extending very high, 30, 40, 50,000 feet up into the air, that becomes really challenging as far as how much of that is going to come down on our heads, on our property, flood our yards, get into our basements, cause people on the roads. And that is sort of the double-headed dragon, so to speak, as far as forecasting goes. You want to be accurate, but you want to be able to make sure that you're giving people a realistic expectation of what to expect when it comes in terms of tangible amounts, impacts, rainfall totals, snow totals, etc. The more humid the more unstable the atmosphere can become. Just talked about this with different sort of mechanisms causing air to lift, causing air to rise. It becomes really tricky as far as how impactful this weather system is going to end up being. Real quickly, in September, we had a tornado outbreak. We haven't had a September tornado outbreak in Massachusetts in a very, very long time. And this monster supercell pushed through Massachusetts and dropped a tornado 5 separate occasions. And it was really damaging to property as it pushed through. But what was most alarming is how impactful this tornado was, because the ingredients were there in the atmosphere, but how quickly this tornado developed based on the instability in the atmosphere really made it eye-opening as far as, wow, okay, so this severe weather, this 5 years ago, 10 years ago, probably wouldn't have produced a tornado. But having more air interacting with cool, dry air, different shear wind patterns, which is the change in speed and direction with the air as you rise vertically into the atmosphere, everything's become amplified, which makes forecasting much more trickier across the region. Speaking of severe weather and hurricanes, talking about which is the convective available potential energy, sort of the ingredients like I just mentioned when it comes to severe thunderstorms and the potential for tornado, hail, cloud to ground lightning, intense torrential downpours. This calculation is determined how much energy is available to fuel a thunderstorm. The higher the CAPE value, more CAPE at 1,000 usually results in severe thunderstorms. Well, I don't have a chart for this, but I have a log. And the number of severe thunderstorms in the past 3 years across Massachusetts has shown CAPE values into the 2,500 to 3,500 range, which is very new for New England. We didn't have the technology back then, I'm sure in 1953 with that famous F5 tornado in Worcester, but I can imagine what the CAPE level was, and you're getting close to that figure when it comes to the CAPE or that sort of severe thunderstorm setup. New England has seen 20 to 40 more severe thunderstorm days since 1979. You can see the entire eastern half of the country, east of the Mississippi, has increased with available thunderstorm potential based from data from Climate Central. And that means our severe thunderstorm season is longer and it's becoming more extreme. Again, going back towards the September tornado outbreak that we had, those CAPE values were triple the amount of energy available for these storms to tap into, to produce a tornado, to produce hail. I've looked at hail reports over Massachusetts just this summer alone. We've had a higher number of quarter-size hail or larger, which is really unique because, again, you think of the atmosphere as a 7-layer cape or as a 7-layer cake, and that means more water vapor available in the higher atmosphere. When you get these thunderstorms that draw a massive updraft to basically elevate any precipitation, water, whatever the case may be, and that updraft becomes so strong, it reaches into the higher levels of the atmosphere with this water vapor, sitting there, sort of like gasoline, just waiting for a spark to be tapped into. Well, these water droplets, they freeze when they get up to this freezing mark, and there's this water vapor available, and you get these large hailstones that eventually become heavy enough to drop through that strong updraft and fall on our heads, our vehicles, our roofs, etc. But it's just interesting to see, just this summer alone, when we had severe storms, we had an increase in the number of hailstones and, the size of the hailstones falling on our heads. It sort of makes it feel like New England is transitioning into sort of a southeast type of to severe weather. Hurricanes for New England, and fortunately, we were able to avoid so far a U.S. landfalling hurricane this year. We did have Tropical Storm Chantal in July make landfall in the Carolinas, but we haven't had a landfalling hurricane in the U.S. since 2015, which is a good thing. This is very happy to report this. But just sort of like how things are developed wise with the hurricane, we have what is called the Bermuda High, and it lives semi-permanently. I only say semi because it lives permanently, but it shifts from the East Coast all the way east towards Portugal. It sort of floats back and forth across the northern Atlantic. But this system helps direct coastal lows and tropical systems towards or away from New England. It's very close to New England this weekend, and that's why this coastal low is going to develop starting basically tomorrow afternoon off of the Florida coast and the Carolinas coast, and with that high pressure pushing towards the East Coast, towards New England, that track is going to ride right up the East Coast and then into New England. This is where, although we're not going to have a named tropical storm, this nor'easter is essentially a sister of a tropical storm, because we just don't have the textbook definition of a tropical storm in place, which is you need 80 degrees or warmer sea surface temperatures to fuel the storm in order for it to be considered tropical. Sort of a moot point. A storm's a storm. A nor'easter is very powerful. And if you had to ask me, is this a tropical storm-like storm coming? I would say absolutely. But the natural pattern is amplified because of climate change. With warmer sea surface temperatures, particularly across the northern Atlantic, the Gulf of Maine, it becomes more erratic as far as which direction these storms will go, particularly hurricanes, since we have it on the screen. But that goes to nor'easters as well. In this case, for this coming holiday weekend, we're seeing a deep trough, similar to this graphic here, extend south across the southeast and then push right up over New England. That jet stream is going to be driving right over our heads. And with that high pressure in place, we're going to have that nor'easter right in our backyards. Increased sea surface temperatures provide uninterrupted fuel supply to coastal and tropical systems and build storms stronger and larger. Sea surface temperatures departure from average in the North American basin has been above average since 2018. So this graphic here shows that since 2018, our sea surface temperatures in the northern Atlantic, basically take the equator, shoot right up to the poles, that northern Atlantic. It does include the Gulf of Mexico, includes the Caribbean. The sea surface temperatures have been well above average. What does that mean? You've probably heard of a term been thrown around by meteorologists, rapid intensification. That means that there is a power supply that is amplified across the northern Atlantic, those hot sea surface temperatures that allow storms to develop in the first place, but then rapidly develop stronger and faster, which is very alarming. We saw Hurricane Erin this year. Fortunately, that storm did not make landfall, but that storm became a monster. It went through rapid intensification, increasing in wind speeds of greater than 35 miles per hour in less than 24 hours. The stat had, it was 90 mile, I think it was 85 or 90 mile per hour increase in 24 hours for that hurricane, that is pretty powerful stuff. You know, there's a saying, a hurricane has enough energy to power the globe 7 times over. And that's true. It's been thought and plotted out. But to see that much energy for a storm to increase in strength by 90 miles per hour in less than 24 hours, that is pretty alarming. And I referenced this earlier, the Gulf of Maine is the fastest warming water body across the globe since 2004. That is extremely concerning in a case of what we've talked about. Our summers are beginning sooner and ending later. Our winters are warmer. We're seeing more rainfall during the winter than snowfall. We're seeing a steeper temperature gradient and an air pressure gradient between inland New England and the northern Atlantic, or the Gulf of Maine. That amplifies winds. Boston this year is experiencing the windiest year on record. That dates back since weather reporting began in the mid-30s, 1930s at Logan Airport. The windiest year on record, and that's because of the warmer Gulf of Maine interacting with our inland patterns, creating, if it's not rain, if it's not severe weather, well, you're still walking down the streets of Boston, Framingham, Worcester, everywhere in between, and it's more windy because we could feel that difference. So how is New England, how's the coast faring against rising sea levels? Well, unfortunately, it doesn't take a lot of thought to see this increase on this graph. This dates back to the late 1880s. And starting globally, The average sea level has risen 8 to 9 inches since 1880. In 2023, the average sea level was almost 4 inches above 1993 levels. So not only is it increasing generally, but it's increasing at a faster rate, faster than we've ever seen before. It's the highest annual average since records began in 1993. The rate of rise is accelerating, doubling in the rate from 2015 to present. So that's 10 years. 10 years we saw the rate of Slack channel, and we all talk about this on at least a weekly basis. And as far as long-term modeling goes, it looks like we're going to be at least staying at a double rate of increase, but triple and quadruple is definitely doable within our lifetimes, and that has major and that's everywhere. You can see the New England coast waters 2 feet higher seas modeled out on this graphic here. They may rise as high as 2 feet within the next 50 years alone in some spots. Since 1950, Boston has seen sea levels rise 8 inches. That is substantial. We just had our king tides this week, when you have the moon and the sun, both with the gravitational influence on the earth, making our naturally occurring tides, high tides, much more dramatic. You've probably seen in whatever publications you follow, whatever news channels you watch, the splashover along coastal roadways across the Boston Wharf from these king tides. And 8 inches in 75 years is a significant increase. And if that rate continues, a normal high tide, we wouldn't have a king tide that happens a handful of times per year. A normal high tide will result in splashing over, which is a major problem. That's why insurance companies are leaving coastal communities. That's why premiums are doubling, tripling for some towns and communities, especially along the Cape and the South Shore. Coastal New England has seen sea levels increase a foot since 1900. This is higher than the global average. The low slope off the northeast coast makes the area exceptionally vulnerable to coastal flooding and erosion. So our slope off the shores, the gradient's relatively low. So we feel just the slightest increase more dramatically than the West Coast, which they have a very deep trench happening right off the West Coast, and that allows a little bit more room to breathe in terms of sea level rise, becoming more vulnerable at a more dramatic rate, just because of how our blueprint is shaped and formed underneath the Gulf of Maine. Not a lot of room there for folks to, or not a lot of room for the excessive water to go, except inland. And with these tides that occur daily, and the king tides that occur multiple times per year, we're seeing just that much more water push inland. A handful of case studies as we kind of dive into real life examples of significant flooding, the extreme weather that we've experienced over the last couple of years. Vermont 2023, that was a significant flooding event where the terrain came into play, the atmosphere came into play as far as how much water actually wrung out over our heads. A large coastal low moved over central New England and stalled. So much moisture in the air, dew point temperatures into the 70s. I wrote a story about a month ago, quick sidebar, about how our summers are becoming more muggier. And I'm sure you've all felt it. We've had a tremendous amount of days this summer where our dew points were in the 70s. Over the last 3 years, we've had more 70-degree dew point days than ever seen on record, dating back at least 60 years, depending on which weather station or which weather reporting site that you refer to. But over the past 60 years, the last 3 have seen warmer air, more water vapor, and it becomes much more comfortable, or much more uncomfortable for us to go about our daily life with dew points that high during the summer. Makes Boston, makes our region, makes Framingham feel more like Baltimore or Charlotte, North Carolina, or Charleston, South Carolina, in terms of the type of air that we feel during the summer. Again, not to go off track here, but you could have a completely different discussion on what this means for our ecology. What does this mean for our plants? What does it mean for our trees? What does it mean for fall foliage? We've seen fall foliage the last 2 years be muted or shortened dramatically because of how hot it's been spilling into fall, the lack of precipitation, coming from extreme drought over the last two falls. We've seen our fall foliage not produce as vibrant leaves just dropping without even changing color. We've seen a rise of beech tree disease, which has really impacted just how beech trees behave. They sort of, the trees give up and let this heat sort of led disease spread through the leaves and take away the natural foliage process for many of those trees. Alarming, the real life impacts, just increased humidity, increased dew points across the region. I think real life example, heating bills, right? You're running the AC all throughout the day, 4 hours a day, because the dew points are staying elevated at night. People aren't finding relief at night. You're not able to crack your window open to find relief after a hot summer day. Those temperatures stay elevated, the dew points stay high. You're relying on your air conditioning to allow you to sleep comfortably, and you feel it with your wallet when the heat bill comes in, or when the AC bill comes in, and you're paying $300-400 a month. It's not sustainable. It's a real life consequence to some of this climate change derived weather that we've been experiencing. But anyway, back to this extreme flooding Vermont example. 3 to 10 inches fell within 48 hours, breaking numerous daily records, flooding Montpelier, as you could see in the image. The steep terrain didn't help anything at all throughout Vermont. Exceptional runoff and extremely rapidly rising rivers just made water rushing to lower lying areas, towns, community, infrastructure, wiping out bridges, just like a brick wall, just plowing into these structures and demolishing roadways, homes, businesses, and everything that was within these debris flows away. Remnants of Hurricane Ida in August of 2021 took a really interesting track meteorologically, but unfortunately a devastating track, because if you were to cut a plus sign through a hurricane, the most significant portion, the most deadly portion or impactful portion of the hurricane is in the northeast quadrant. So when Ida pushed through, albeit it was just remnants, it spilled over the Long Island Sound and was drawing that counterclockwise flow into New England and brought 4 to 8 inches of rain within a 36-hour window. The storm was moving slowly, and that brought extensive flooding across southern New England. So much so the Northeast alone saw $16 to $24 billion in damage with the remnants of Ida. Numerous tornadoes also caused local damages that range in the millions from the system. And this, going back real quickly, and how much time it spent over land. That's after its supply of fuel was cut off, and it stayed strong enough intact to be able to redraw moisture from the northern Atlantic once spilling over the Long Island Sound, and then bringing some devastating rain into the equation. The March 2023 nor'easter, a very strong system, came in, plucked out so much moisture from the northern Atlantic, also a very for the Gulf of Maine and the northern Atlantic in terms of sea surface temperatures. And even though it's March, Even though sea surface temperatures were low, they were in the 40s and low 50s and in some spots. It didn't matter relative moisture to be drawn out of the northern Atlantic and supply fuel to this storm to strengthen as it lingered over New England. It dumped 2-inch per hour rainfall rates across parts of New England, resulting in inches of snow. That's 3 feet of snow. The equivalence of that, boy, that's a lot of snow in the late part of the season for New England. Wind gusts range between 50 and 60 miles per hour. Heavy snow, wet snow, took out many power lines. Broken tree limbs took out power lines as well. Over 200,000 New Englanders lost power. Many homes dealt with subsequent flooding from melting snow and following rain events. The reason why I referenced March 2023's nor'easter is the storm was powerful in itself. But then right when the storm passed, we had all the snow on the ground, and then we had a very dramatic warm up, and that snow melt paired with more rainfall just amplified flooding. There was nowhere for much of the rainwater from subsequent storms to go, and the flooding and the snowfall itself, that meltwater flooded many rivers, creeks, low-lying areas, and then eventually pushed into property, residential, commercial, and resulted in many, many millions of dollars of damage and loss. So this gets to the point of the discussion where we think about adapting to extreme weather in a practical sense. There's an initiative that's been in place for some time, but really over the last couple of years, we've seen a lot more motion from it, the Resilient Mass Plan. It sets out really local, state, and federal agencies working together to help take action against things like coastal flooding, erosion, extreme storms, looking into how buildings are built and how they could be reinforced to combat extreme weather, especially flooding in high-risk zones, which happens to be mainly across low-lying areas and across the coastal plain. Multiple proposals have been in place for the restoration of salt marshes, dunes, barrier beaches, and wetlands, which naturally buffer coastal flooding and reduce wave energy. This has been more of an aggressive move, especially across the Cape, the islands, the South Shore, parts of southern Rhode Island, to really combat and protect the property that are ocean fronting and shortly inland. Salt marshes are great. They have very deep roots. They're like planting sponges in the ground. They hold and retain water at an exceptional rate. And this has been in motion for the last few decades, but more particularly, we've seen action in the last few years for them to actually become more proven and more in place in real life scenarios. And the question on the other hand, the other side of the coin is essentially how much, is it a little too late? Are we able to do it? Are we able to reinforce everywhere at a fast enough rate? And unfortunately, I don't think that answer is yes. From a individual standpoint, staying informed is crucial. Paying attention to local news, radio with alert notification on your weather apps came into play big time in September with those tornadoes. They were in the forecast. There was a chance for a tornado in the forecast, but when that storm cell came together, it came together very quickly. And the lead time for a tornado on the ground was fortunately north of 20 minutes, but being informed allows you to basically see it before it happens, which is nice. Preparing your home, an emergency kit is essential. Plan to have food, water for 3 days. Trim branches away from your home, your roof, the power lines, and secure loose objects in your yard. There's a severe weather checklist on my left here, where some practical things to keep you informed when severe weather unfolds. That is going to be crucial for you, because there's been times, I think of last year, when North Carolina was hammered by a hurricane that spun out directly overhead, and that town, many towns rather, spent 7, 10, 14 days without electricity, which is ridiculous. And being able to have an emergency kit is essential for survival when it comes to it. Listening to evacuation orders, the National Weather Service, National Hurricane Center, any of these agencies, they don't want you to leave your home. They know how much of a burden it is to people. But it comes down to a matter of life and death in these scenarios. And that's why sometimes we resort to these evacuation orders, and they're to be taken seriously, because no one is bored in their office and just doing something to do something. It's looking at all the measurables and learning that there is a significant chance for destruction to occur. So when an evacuation order is in place, it's essential to listen to it, and listen to it fairly quickly. But that's it for me. I really appreciate you all attending and listening to me chat about weather, climate, and extreme weather events building throughout New England. And I would love to dive into any questions that you all may have. I'm going to pull out the chat here in a second. If you have any questions now, you could drop them in. I'm going to scroll right up to the top. All right. So someone says here, Sue says, I think of the ocean as a giant bathtub. How can the ocean rise more in this area? Well, yeah, that's a great question. And I could think of the ocean as a bathtub as well, especially in terms of temperature. But going back to the way that the New England coast is shaped, you have, and there's a very slow gradient, or very low gradient of geography below the ocean, below the ocean waters. It doesn't drop out where there's plenty of depth there. It's very any sort of movement, any sort of additional water will be felt more dramatically across the Northeast coast versus other coastlines across the country, because of just how little room there is. So unfortunately, when there is a dramatic storm, or if the rate of sea level rise increases, there's nowhere else for the water to go except up onto our shoreline and create a new shoreline. And that's what we're seeing. We're seeing retaining walls built higher so it could be able to hold more higher. It's like having, a cereal bowl versus a salad bowl. They're trying to make it where the coastline is becoming more like a salad bowl, where the walls are higher, these sea walls, and they could retain much more and slow down sea levels. But unfortunately, there is no place for the water to go except for inland, and that is the track that we're on. Mary says, there is to be king tides this weekend. Do you feel with climate change that we can expect these types of tides more often with greater impact? Yes, I think that we're going to see our normal daily tide become problematic by the year 2035 to 2045. With the rate of sea level increase, just our typical high tide is going to be more impactful, because it's already reaching some areas threshold as far as sea level or sea barrier wall depth, and also infringing on the coastline, eroding beaches, making it more vulnerable for our tides to have more of an impact. if we continue to add another 8 inches of water in 50 years, 40 years, as I mentioned, it may be even at a faster rate, so we'll say 25 years, then that is a tremendous amount of water in our natural diurnal tide cycle to push up against our coastline and spill over. We're going to have our king tides just be much more dramatic because of it already. King tides bring our normal tides to about a foot higher than normal. Coastal flooding. Think about adding another 8 inches onto that. That's going to push water further inland. That's going to create new coastal inundation, coastal flooding for king tide events for new areas in the future. So unfortunately, I don't think that we're going to have much fun with our normal high tide cycle in the next couple of decades. Mary Seiferian, sorry if I mispronounced your last name. How is Montpelier now? Have they built anything to prevent river overflowing? That's a great question. The short answer is they are much improved. They're touched since 2023. However, some of their deepest have been dug deeper, 2 feet deeper, to try and curb spillover at the most vulnerable weak points across the city limits. So there has been some efforts where when the inevitable does happen over the mountains funneling towards the valley of Montpelier, hopefully they're better equipped. Hopefully we won't see the magnitude as what we've seen in 2023. That was a very dramatic, a very rare flooding event, sort of a perfect storm, have you? But they have made some improvement with the vulnerabilities in some of the rivers and stream beds, digging deeper and reinforcing the bankings to try and keep the water flowing away and into more natural areas. Susan just sends in, with the current U.S. administration, do you have concerns? Oh, there we go. Do you have concerns of personnel cutbacks and funding to agencies, National Weather Service, that serve this country with weather information and aid to those communities that have been impacted by significant and destructive weather events? Look, Susan, I dove into this when NOAA was slashed months ago, and yeah, the short answer is I do have concerns. There is lapses at many National Weather Service offices with the type of data, the type of data that's needed to support forecasting. I'm not going to speak to which sites and where, but there have been cuts in New England, and I've seen the impacts from it, just as far as, working hand with the National Weather Service with what I do every day. And it's unfortunate. Many stations across the country were able to release weather balloons multiple times per day, which is so crucial to helping forecast. And that just makes the puzzle. Imagine trying to solve a puzzle with 700 of the 1,000 pieces. It makes it incredibly difficult to do, and it's unfortunate. There was also another satellite, a satellite that was really good at scanning an MRI of a tropical storm that has been discontinued, which has made forecasting hurricanes and tropical storms much more problematic. So that I could talk about that for hours. Same sort of scenario, getting handed 80% of the puzzle and trying to fill in the gaps with I don't want to say imagination, but with the data that you're given. And with that, there's going to be more difficulty in accuracy as far as storm track, intensification, etc. We've seen that happen already this year. Unfortunately, that's a real life scenario that is unfolding, and hopefully, the folks get relief at the federal and state level with the National Weather Service and NOAA as an agency. But yeah, we have seen the impacts in forecasting from these cuts, which is unfortunate. Let's see, I think we're a little bit over on time. I'll answer one more question. Carol, great presentation. Thank you. Of course. For example, do folks know that just eating less red meat can help lessen climate change effects? That is just one example. Yes, about things that you could do for climate change. The short answer is there's a tremendous amount of things that you can do to help curb climate change that is put into the things that we consume, the things that we buy, the things that we that interest us. The best thing that I could suggest at this point, at this juncture, is take your time to look into, whatever it is that you're interested in. If it's something that you eat, something that you want to purchase, something that you want to, or something that you want to explore, take an extra few minutes, see where it's come from, how it's been put together. And if you want to make a conscious effort, by all means, I think every little bit counts from an individual level. And but yeah, that's a great question, Carol. That probably deserves its own presentation in its own right. But there are, the one good thing about the access to information these days is you can find good resourceful information that helps your decision making, especially when it comes to our carbon footprint and curbing climate change. A quick last one from Mary. Salt marshes are being restored. Nantucket and Martha's Vineyard have had a big initiative. There's been coastal towns on the facing ocean facing sides of Cape Cod where restoration has been happening, and it so far has been proving great. It's just a matter of all of New England needs it at some point, and can we help folks out before the next major storm arrives? Can we help folks out before another 2-inch rise in sea surface levels, or sea levels rather? We're unfortunately kind of speeding against the clock, which doesn't really help us out. But I'll stop there. I really appreciate everyone taking their time and hopping on and listening to me talk about the weather and climate. Feel free to follow along with what I do every day at the Globe, Instagram, Twitter, Blue Sky. I'm sort of everywhere. But stay safe Sunday night and into Monday. It's going to be pretty windy. We haven't felt winds like this in a while, so it's going to feel worse than it actually is. But 40, 50 mile per hour wind gusts are no joke. So make sure you just spending time in your backyard, securing everything, and take a peek at any tree limbs that are near your gutters or near near the power lines that you could safely remove. So with that being said, I'll pass back over to Sarah, and I really appreciate everybody joining in tonight.
Thank you, everyone, so much for coming in. And thank you so much, Ken. I know that people really appreciate you coming in. Thank you for being here with us again.
Absolutely.
For folks who are interested, our next lifelong learning lecture is going to be on November 6th with John Hebrexa from the Framingham State University on conspiracy theories and why people believe them. So we hope to see you then. Ken, thank you very much. And everyone else, have a good night.
Thanks, everyone.
Thank you.